Okay, hi everyone. Now let's look at another LeetCode problem. So this is problem 417. Uh, Pacific Atlantic water flow. Okay, so problem question. There is an n times n regular island that borders both the Pacific Ocean and Atlantic Ocean. The Pacific Ocean touches the island's left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. The island is partitioned into a grid of square cells. We are given m times an integer matrix heights, where heights RC represent the height above sea level of the cell at coordinate RC. The island receives a lot of rain, and the rain can flow to neighboring cells directly north, south, and east, and west if the neighboring cell's height is less than or equal to the current cell height. Water can flow from any cell adjacent to an ocean into the ocean. Okay, return a 2D list of grid map coordinate result where result I equals Ri, Ci denotes the rainwater can flow from the cell Rici to both Pacific Ocean and Atlantic Ocean. Okay, so now let me read the problem to make sure I understand it. So there is an m times n rectangular island that borders the Pacific Ocean and Atlantic Ocean. Pacific is top and left. So we are given m times n. The island is partitioned into a grid of squares, so we are given m times n. Integer height. Okay, so we are given the height of m times n. Return a 2D list of coordinates that makes the water can flow from RICI to both Pacific and Atlantic Ocean. Okay, so m times n Pacific and Atlantic. So left and top. Atlantic Ocean. Pacific Ocean is on the left and top. EO. And then the right and bottom is Atlantic Ocean. Okay, so basically we need to hold on. let me see. So a flow is gonna flow from less than or equals to the current cell height. Okay, so a flow is defined when a height so if we have hs flow to hy, then it means that hx is greater than or equals to hy. Okay, now we want to return the list of coordinates where the water can flow from Ri, where the water can flow to both oceans. So, okay, I think I understand the problem now. Let's look at some examples. So example 1, we have 1, 2, 2, 3, 5, 3, 2, 3, 4, 4, 2, 4, 5, 3, 1, 1, 6, 7, 1, 4, 5, 6, 7, 1, 4, 5, 5, 1, 1, 2, 4, 1, 2, 4. Okay, so let's find out all the cells where the water could flow into both oceans. So first cell, okay, all of the first row and first column are, so all of the edges that touches only one. Actually, it's not the case. Yeah, anyway, I think we need to check all of the edges here. But then if we look at this, first cell there is impossible. Second cell, you also know it won't go there. Then in here, basically the cells are in the first row, only 5 is possible. Second row, let's see if it can reach anyway. Second row, it's only the 4, the last 2 cells. In the third row there is 5. Fourth row there is 7 and 6. Then the last row, that is 5. Okay, so that's are all of the coordinates. Now let's look if there is a second example. Okay, second example, there is just one cell. So if there is just one cell, then it can reach anywhere it wants. And basically that is the answer. Okay, I guess I understand the question now. Let me explore some possible approaches for this. So off the top of my head, I think what we can do is we can brute force all of the cells. But before that, let me clarify a few things. May I know the size of the M&M? So here we are given that M&M between 1 to 200. So we know that the grid is valid, and by valid I mean there is at least one cell. Okay, and yeah, I think that's all that I want to clarify. The height of RC is between, I think that is irrelevant. I don't need to know that, but I think it's reasonable for that number. And now let me explore some possible approaches for this problem. So as I mentioned before, what you can do is could do a BFS or even DFS from any node or from other node, and then check whether there's a path that could reach the top and bottom. I mean the top left or and the right bottom. Okay, if it could, then we add it to our list. So I think uh, one thing that we notice here is that if a cell can, so let me put down the findings here. So one, I'm gonna define a result. Okay. Let's see. Okay, so if we know if there is a flow that is possible from uh, a cell to any of the result, then we need to add the cell to result. Basically, what it means is that if we have found a cell can reach both oceans, and there is a cell which can flow through that particular cell, then basically that cell is also part of the solution, because from that cell we can flow to the the we can flow to a cell that is part of the solution, meaning that it can flow to both ocean. Okay. So I think that a general solution for this problem is that a cell could reach the ocean if at least one of the neighbor could reach both of the ocean. Okay, so that would apply to the cells in the middle. I mean not at the edges. Okay, so the cell at the middle equals, we take the R of all edges of all cells in the neighbor. Okay, so for the edges itself, then the answer would be cell of edge. Then this would be the R of cell neighbor. You can also take the R for the edges, but the requirement is slightly less stringent because we only need the neighbor to access to the other ocean. The other ocean. Okay, so I think that would be it. So now what we're gonna do is that we're gonna go through all the cells and then find a way to reach the ocean. So I think we need two arrays, two different arrays to indicate whether we could reach two different oceans. So I would say we need one grid to check whether we could reach the Pacific Ocean, and then another grid to indicate whether we could reach the Atlantic Ocean. And then in the end we just need to OR them So let me write down the step first of all. Step 1, create grid PO and AO. So PO and AO will indicate if it is the indicate flow to ocean. Okay, then the result PO, and then we take the OR. Actually, it's not OR, it should be the AND. So if we take the AND AO, then this would be the result. Okay, so I think this should work. Now I would like to go through the example again to make sure we can get this right. So example 1, we are gonna create a grid. So let's work on the PO first. So Pacific Ocean can be read from all the edges on the left and the top. Now we just need to check for the other cells. Let's see. We have 2, 3, 4, 4. So that's all could be 1, 1, 1, 1. And then the next row will be 2, 4, 5. So 1, 1, 1. So 3 cannot go anywhere because it's kind of surrounded by taller cells. And then 7, yes, no, and this one is a no. This one is also a no. No. Now we create another grid for the Atlantic Ocean. So this be 1, 1, 1, 1, 1, 1, 1, 1. Okay, so here is 1 that is reachable, unreachable. 3, 2, 3, that is unreachable too. Then that is reachable, that is unreachable. 1, 1 is not reachable. 7, 5, 4. Okay, so now we have both the grid. Then we just take the OR. So if we take the or, then basically we are done. I think. Yeah. Okay then. Um. Okay. So here is what we are gonna do then. First of all, we initialize the edge, the stuff that bordering with the ocean, and then we set it to true, and set. So step 3 is we set our border to 1, and therefore itself we are gonna do a BFS to find a way. And one thing that we need to note here is that once we so step 4 use visited, we can use a visited grid so that we don't do a BFS multiple times, because if we have previously do a BFS on that cell, then basically we don't need to check that anymore. Okay, so I think I'm pretty good about this. May I start programming? Um, so the step number, let me just add one more thing. Step number 5, we do BFS on the neighbors. Alright, so I think I'm pretty good about this. May I start coding? I assume it is gonna be yes. So let me work on the solution now. First of all, as we said, we're gonna create 2 additional lists. So I'm gonna call it Pacific and Atlantic. So let me just let's see. Okay, I'm gonna create a BFS function. And I will do this. Let's see. Okay, I will do it iteratively. I think iteratively is much more difficult to implement, so I'm gonna challenge myself to write a iterative solution. So define a BFS the O. Okay, so O of ing. So first of all, I'm gonna check if the value in the current cell has been visited or not. Actually, in here, I'm gonna use the same grid to indicate whether I have visited the cell or not. And I'm going to do so by using none. So none will means that I haven't checked that cells. Otherwise, it would be true or false. True being it could reach the ocean, and then false is otherwise. Okay. And now, what I'm gonna do is I'm gonna check the O at I and J, or let me just call it X and Y for better naming. So if O of XY is not none, then you're gonna return it. Otherwise, if it is none, then we need to check the surrounding. So let me call it a check variable, which is initialized to false. Then for our direction, for the SDY in direction, I'm gonna check. Okay, let me just directly use that variable. So OXY equals OXY, and then we OR this with the BFS of O x plus bx, y plus by. Okay, and then in the end we will again return the current cell value. Okay, we need to initialize it to xy equals false. Then we return OXY. Okay, I think this looks pretty good on the BFS. Now we need to create the grid and then work on the BFS. So let's call it Atlantic and Pacific. So Pacific equals, so let's create the list of lists, initialize to none. and then times length, or is it height? Yeah, height of 0 for I in range length of height. Okay, now we do the same for the Atlantic. And now it's time to do a VFS. Actually, hold on. We haven't set the edges for the Pacific and Atlantic. So for Pacific, we need to set the top. Okay, so let me write a loop here. So for I in for X in range of length or height, and let's see. So Pacific is the top and left. So it means that, okay, so here is what you're gonna do. So Pacific of X of 0, these are all true. Like for Atlantic of X of -1, this is true. So this would be setting the left and right. And then for Y in range, length of height of 0. Now this is setting the top and bottom. So Pacific of, let's see, 0 and Y. Now this is true. While for Atlantic, this would be the -1, and the Y equals true. Okay, now that we have set the, I think we can call this the beaches. That is a beach that kind of next to the ocean. So these are our edge cases. Okay, so now we got all the borders right. It's time to do a BFS on all the cells. Okay, so for X in range, length, height, for Y in range, length of height, 0, then we do a BFS on the Pacific and Atlantic. So Pacific XY and BFS Atlantic XY. Okay. Actually, I think we could do directly checking the solution if BFS XY Atlantic and Pacific, then we add it to our solution. So we call it result. And then if these two are true, then we add it into our result. Result.append xy. Okay. Actually, append we don't need that. Anyway. Now let me quickly go through the code again to make sure I don't miss anything. First of all, I create a grid of the same size called the Pacific and Atlantic. So this would represent whether we could reach the Atlantic Ocean and also the Pacific Ocean. And now I set the boundary. For the Pacific, it is the top left, top and the left. Now for Atlantic, it is the right and bottom. Okay, so that is what I'm doing in the two for loop. And now the last for loop, I'm gonna check whether the cells at x and y could reach both ocean, and if so, I'm gonna add it into our result. And finally, we return the result. Now let's go through the BFS. If O of xy is not none, then we return it because we have checked it before. Otherwise, we go through all of the neighbors and then we take the OR of all these neighbors. Then set the value. Again, we return the result. So I think that should work. Now let me quickly go through the example to test our code. So previously we have example 1. Now we see that we have set all the boundaries, and then we go through each cell and then check if there is a way to reach the ocean. If so, then we set it to 1, so on and so forth. Then we take the OR, the value. So I think this should work. Now let me input our solution into LeetCode to make sure it works as expected. So find BFS OX Y. So this, let me call it ocean. If ocean of xy is none, then what we're gonna do is we set it to false. And then we go to the neighbors or dx, dy in direction ox y equals itself, and then or whether BFS of the ocean x plus dx, y plus dy. Okay. Then in the end, we return ocean of x and y. Alright. So that would be it for the BFS. Now let's initialize the Pacific and Atlantic. Pacific equals none times length of heights 0 for all in range length of height, and then the same for Atlantic. Now the border adds in range length of height. Pacific of x on 0 equals to Atlantic of x of minus 1 equals 2. Now we need to work on the other border. So Pacific of 0 of y is 2, and then Atlantic of minus 1 of y is 2. Okay, so now it's time to check our solution. Check the result of our output. So we need two for loop, nested for loop. And then don't forget to initialize the result to empty string. Then here, if Pacific or if BFS Pacific x y and BFS of Atlantic x y. So let me just call it a flow. Okay, to make it more clear. Flow. Then result dot append x y. Okay, in the end, we return the result. Now let me try to run this. The x y direction. Okay, so you forgot to initialize the direction. So direction equals, we have done this multiple times. Minus 1, 0. 1, 0. 0 minus 1. 0, 1. Okay. Ocean of, okay, so this is flow. Apparently we got a wrong answer there. Looks like we are adding all the cells, so something is definitely wrong. Okay, so let's see what is wrong here. Ocean of fire. Okay, we forgot that there is a boundary which is so important. I don't know why I missed that. Okay, so Now I'm gonna do this. Okay, so before this, we need to check if it is valid or not. Okay, let's do that. So if let me call it new x. Let me just use an ing. So I is x plus dx. Then this is y plus dy. So if I is less than 0 or j is less than 0 or length of ocean is less than or equals or the length. Actually, I could just use equal. I equals length of ocean. J equals length of ocean 0. Then we continue. If ocean of ij so we need to check whether it is possible to blow that or not. Ocean of ij, and we continue. Ocean of x, y. If it is lower than the new cell that we are going to enter, then it is not possible to go there, so we just continue. Okay, so let's check this. Length of ocean less than is not supported. Sorry, this should be the grid. Height. Right. Right. Yeah. We still got it wrong. Okay, so the height here is wrong. This should be 0. And the xdy. Interesting, we still got it wrong. Let's see. Okay, let's try again. I think it's still wrong. Okay, so I think it doesn't include the x. Is that the case? Not really. So how How about we print out? Okay, let's print out. Print the specific R0 and also the Atlantic. Okay, next one, run this. Okay, so it's all true. Pacific is all true. That is not right. Pacific of x of 0 is true. X Atlantic of x minus 1. So we see the edges are all basically wrong. Okay. Print the before and after. So previously it is all true. I think my initialization is wrong here, I guess. Let me check how I can create 2D list in Python. Okay, so I think I need to do a for loop. Okay, so I print the wrong thing here. Pacific of x and Atlantic x. Atlantic and Pacific. Okay, initialization is correct. Okay, let me print Pacific. Atlantic. Let's see if we got this correct. So true. So let me check with what I got in my paper. First and second row are all true. And then the third row, it is all true until, hold on, that is not right. Okay. if the height of xy is less than height of aj, so the third row 2.3 is not right. Okay, so let's see. 2.3, it cannot go up, it can go right. Pacific and Atlantic. Okay, so the index is wrong here. Sorry about that. Yep, now we got it right. Let's try to submit it. This is out of range. So this is height of 0. Okay, I need some details there. Wrong answer. Output is 34 and 2. Somehow we are missing a cell. I'm not sure what I got wrong here. Okay, let's print out the height. I'm missing 3.27. 1, 2, 3, 27. Okay, so then what happened is that, actually no, I think I missed a requirement or something, because I still cannot figure out where this go wrong. Okay, let's bring up the heights. 7, 8, 9, 12, 13, 14, 15, 16, 17, 18, 19, 20, 25, 26, 27. So 11 can go. Can I just print the whole thing without getting messy? Doing a pretty print. Okay, anyway. Funny, 3.37 is out of range. Oh, okay. Test cases. Let me remove this. Then run it again. So it's 19. 19 I log out, out, and then no, it's not up. I can look to the right. So I can go to the Atlantic or what, the Pacific. Yes, but how come it's not in the solution? Oh my god, it's all none. How is that possible? Oh, okay. It's all none. Is it possible that it is doing a BFS on those cells and then it kind of gets stuck there? Yeah, because if those cells are isolated, then it won't work. Okay, so this needs to be fixed. Yeah. So our BFS is not right. So what we need to do instead is we need to do BFS. Okay, so I think we are doing a wrong approach here. Because if you look at this, it all got none. It means that somehow it got stuck there and it cannot find a way. Then I guess the iteration got terminated because it runs for too long. But somehow LeetCode doesn't throw me an error. And let me think of if there a quick fix here. Uh, hmm. Yeah, because if you think about it, if there is a low flat island surrounded by a mountain, then it will kind of get stuck in there doing all of those BFS repeatedly. Mhm. Yeah, I guess our approach is wrong here. Okay, so I think a quick fix is to use a visit itself. But how are we gonna do that? Okay, let's create another visited. I think this is not the most efficient, but at least for the current approach, I think this would work. we visited. X and Y equals 2. And then here, we need to check if it has been visited. If visited of ij, now continue. Otherwise, at the end, I think we can reset it to false. So let's try this. Still give us a wrong answer. Okay, actually, instead of doing visited, how about if we do the no. I think I'm gonna stop here first, and then I will make a follow-up video on this. It's kind of a wrong approach that we are doing here.